Okay, and we are live. Good evening, everyone. Welcome to the live chat for the week of, what week is this? It is August 24th, 2022. I don't know what week it is anymore. That's what happens when you get older. You lose track of time. So there's a lot to talk about this evening. There's a lot of news that's going around in terms of meteorology, a lot of mall improvements that we're hearing about that's on the way. There's a lot going on with more information about the volcano that went off back in January 15th, 2022. We've been talking about this volcano for quite some time and how it could impact the stratosphere. And I'm noticing some very interesting observations, as have other meteorologists and other scientists who have been studying the volcano. And we're going to talk about that. I'm noticing some very interesting activity in the Atlantic. We'll cover that in a moment. And also changes going on with our 500 millibar pattern and the threat for rainfall on Friday and unsettled conditions for this weekend. And most likely your questions about Labor Day weekend. I'll get to that as well. So we have a lot to cover tonight and a lot to answer. And I wasn't sure where to start, so I figured, you know what, let me start at the top. Let me start at the top of the atmosphere and really get to some interesting data. Now, this is the volcano from January 2015. You guys all remember it. Boom, it blew up. Now, what was interesting about this volcano was that it was an undersea volcano that blew up, created its new island, and also threw up a ton of water vapor into the stratosphere. Now, I did not know what would happen when this occurs. I had some theories. Other scientists who have been studying this far longer than I have been theorizing what will happen. And we've had some very interesting observations in which that a ton of water vapor flooded the stratosphere at the South Pole, and now it's starting to do it in the North Pole. So how does that impact the 500 millibar pattern? Well, in terms of stratospheric influences, what you want to do is look at the winter time periods to get a better view, because that's where you get your more dynamic mixing. You get a lot going on. And here's something I find very interesting. Now, we know that the stratosphere is getting filled with a ton of moisture. And we also are seeing our ozone really crash. Now, part of this is because of the active sun, and part of it is because of this moisture being thrown into the upper portions of the stratosphere. That moisture just doesn't hang around. In that cold air, it also starts to condense. So you get some more cloud cover, and you get cooling happening in the stratosphere. But where is that cooling happening? That is where I am very interested, because normally when you're looking at stratospheric warming and cooling events and impacts on the 500 millibar pattern, you look at the high latitudes. Okay, now your high latitudes are basically 65 to 90 north or south. Okay, so we're looking at the southern hemisphere. So south, let's say at 50 millibars. Okay, right in kind of the middle of where we want to look at. And we're noticing temperatures in the stratosphere really not all that far off. A little bit of warming, a little bit of cooling, but nothing extreme. We see the massive cooling taking place in the mid-latitudes. Now that is interesting. Okay, now let's flip the script and go to the northern hemisphere. Okay, so when you have rapidly cooling stratospheric conditions in the mid-latitudes, you end up with 500 millibar heights becoming enhanced, because your stratosphere is shrinking, which means your troposphere is expanding. So you have a better potential for stronger high pressure systems and upper level ridges. Typically, it also means a warmer environment, more moisture. But the high latitudes, if we continue this theme, feature near to slightly above normal temperatures. Now, there's still some debate on why that's the case, but let's just go with the observations we have right now. And in the meantime, we're still working on all the physical parameters here. But this would suggest that you have the potential for high latitude blocking enhanced by mid-latitude enhanced 500 millibar heights, which, when you combine that, could cause feedback mechanisms into your high latitude blocking regimes like your negative NAO, but it could also warp and displace these high latitude regimes, and what you end up with are these dynamic clashes in the lower levels of the atmosphere where we are, with Arctic air masses and very warm tropical air masses interacting. Now, throw in your weakening La Nina that you're expecting. Now, here's our, let me pull that up here. Here's your La Nina right now. It's a moderate, weak to moderate state right now, expected to weaken. Okay, so you see that right here. You know what's going on in the stratosphere, just complete total anarchy. You have very warm waters here, so any Arctic air mass that's pulling over here is more likely to crash right towards the east coast, because as the air is rising, cold air is coming in. And at the same time, you have this signature in the northern Pacific, where our negative PDO is kind of blunted here. Okay, it's more like a neutral event right now. We'll see if that continues. But this would keep your upper level trough somewhere in this neck of the woods here. If you still have lingering La Nina influences in the SOI values and in your AAM, which is your angular atmospheric momentum, then what you end up with is a strong polar jet stream with a strengthening subtropical jet stream transporting moisture towards the east coast, interacting with polar and Arctic air masses with enhanced warm air masses, and boom, a very dynamic and volatile winter. This would be the type of winter type season, based on what I'm seeing in the southern hemisphere, that'd be very difficult to forecast. This would be the type of winter season that separates the modologist from the meteorologist, because I think you're going to have to think outside the box, because we've never seen this type of moisture being thrown up into the stratosphere and how that's impacting all the other mechanisms, from your QBO to your interaction with La Nina. Does this create a feedback process? Does it enhance La Nina or weaken it? We don't know, because it could lead to a feedback process and keep this whole event going. I don't think that's going to happen, but it makes for things very complicated. And I'm telling you this now because I know that there are, in fact, I already had one email sent to me, individuals sending out winter forecasts already. That's going to be problematic, because there is no way in heck I'm putting out a winter forecast out until October. Okay, I mean like late October. Okay, it might be a little bit later than what I normally do, which is around the 20th. Because just looking at the observations right now and looking at what we're dealing with and trying to figure out how this environment, when you flip it to the higher latitudes, plays out is a huge question mark. And one of the things to consider is that when you are looking at the, let me pull this up again. When you're looking at the southern hemisphere, you're not dealing with a lot of land masses here. You have the Antarctic, then you have Australia and South America, but you have a lot of ocean. So the air mass clashes, the mountain torque, all that stuff is far different. When you go to the northern hemisphere, you got all of Asia, Europe, and North America. And so you have a lot more different clashes involved, a lot more different friction factors involved when you're forecasting. So it leads to even more chaos. So what I'm trying to explain to you tonight is anyone that issues a winter forecast right now, you might as well just take it, roll it up, and burn it. okay? Because there are far too many unknowns, even more so than normal. Normally, there's too many unknowns this far out, but you could say, okay, Enzo state is this. We're going to copy paste whatever the climatology for that is. There's your winter forecast. That's what you get right now for this time of year. But you can't even do that because a fundamental factor in the atmosphere, which I think is also influencing what's going on in the tropics in the summer and enhancing the 500 millibar heights over Europe, which is transporting all that dust and creating havoc with the tropical forecast. All of that is in play. Chaos theory is in play. Meanwhile, talking about the tropics, well, take a look at that little bugger right there. Let me zoom in here. Now, the National Hurricane Center is keeping an eye on this disturbance and this disturbance. If I may, I would also include that disturbance. All right, now here's the analysis. Just notice again, they're focusing on the African coast and this disturbance out here, but this one looks, well, it looks awfully healthy. And when I take a look at the wind profile out here, there does seem to be a circulation associated with that tropical disturbance. And there sure is plenty of convection. So we're going to really keep an eye. This one really could fire up here. We could be dealing with a string. We go from nothing to 3 possible systems if we believe the model guidance. Now, a bit of caveat here. I know that everyone and their grandmother is showing the GFS or the European guidance 10 days out, tropical systems, even 15 days out, making landfall on the Gulf Coast, the Mid-Atlantic, New York City, all this sort of stuff. You cannot use the model guidance until you actually get a secure warm core low, a developed warm core low. And I'm going to explain to you why. You see the satellite picture here? You see how this convection is developing and see how it's starting to evolve here? Now, once it becomes a sustained warm core low pressure system, it fundamentally starts to change the surrounding environment, okay? Because you start to have outflow and you start to have upper level high pressure over this and a cyclonic flow at the surface. And it fundamentally changes the wind pattern, especially as the storm intensifies. The model guidance is not very good in handling those type of changes and influences because they're on the mesoscale beta, small scale environment. So what you want is to establish the warm core low, have the model guidance ingest that data, incorporate what's going on surrounding the atmosphere and how that influences a 500 millibar pattern around it, and then extrapolate out to start to get a better idea of what the threat is for the United States. Now, as I've been saying for quite some time, the base pattern we are in, Western Atlantic Ridge trying to build towards the coast, trough around the Tennessee River Valley, that is a warning sign for the potential, not guaranteed, the potential for either tropical moisture or an organized tropical low pressure system to march this way. However, at this point, you might as well use some model guidance for the bottom of your kitty litter, okay? It's just worthless right now until you get that actual data, okay? So if you see someone posting it, making videos saying, oh, look, it's going to be a dangerous storm heading towards the East Coast, it's garbage, it's nonsense. That's how you pick out people who don't know what the heck they're talking about or just trying to scare you. Because anybody who has a degree and understands the environment involved here would never do that. So I just want to put that out there because I'm already seeing it on social media. So just be prepared for that. So this is looking pretty healthy. We have pretty strong convection developing. It looks like we're getting a little bit of outflow. What I want to see, I can zoom in just a little bit more, okay? What you want to see in the next couple of days, if we actually get a warm core low to develop, is kind of fanning out, kind of like feathering out of the cloud tops here. Because what that means is that you have the warm core low, drawing in the warm air, lifting it up, and expanding out. And the expanding out, the release of latent heat and the moisture, okay, at the top of the warm core low causes an anticyclonic circulation, which causes a fanning out of the cirrus clouds. And so what you see, the way to see whether that circulation is starting to develop is that you'll start to see little feathery images on the satellite picture. Whether it's visible or infrared, you'll start to see that. Now, you can't always tell what the extent of the organization is, but you could at least see, yes, there's a warm core circulation developing, and then we see just how mature it is. So that's certainly something that we're going to be keeping an eye on. We get that one out here. The MJO right now would support more shortwaves marching across Africa. And let me just pull up now the dust image that we normally use. It was down when I checked it out last hour. So let me see. Oh, maybe it's back. Okay, now remember, what we want to see is a reduction. So if we're in this area right here, okay, if we only have like, I think that's yellow to orange, okay, that can be overcome. And what we're starting to see now is less and less dust coming off the African coast. So we might be entering that time period where, hey, activity starts to pick up and we start to see real action start to take place. So certainly something to keep an eye on. By the way, in case anyone's wondering, let me go to the satellite picture back here. This feature out here is still a cold core system. It could pick up some warm core characteristics. Could be like a subtropical low pressure system, but it's not anything that is immediate, okay? And if anything, it would get picked up by this trough and head right out into the northern Atlantic. So I wouldn't worry about that, but I figure I'd cover that just in case you are concerned. So far we've gone over the entire base state of the atmosphere. A lot of uncertainty, a lot of wild cards. We know La Nina is still an influence. In fact, you can see that very nicely here in the SOI values. Let's incorporate the daily values here. And you can see pretty much a steady state. We really haven't seen much change. I don't expect a real significant weakening of our La Nina until we get to early October, and then you'll start to see a free fall. So La Nina is going to be an influence in the finish of our tropical season. So that is for sure. So we know what the steady state is. When we take a look at our radar, in our surface map from WeatherTap, we have a lot of activity here. What stands out to me? Well, even in a La Nina pattern, our subtropical jet stream is still pretty active. You typically don't see this type of activity and these type of waves of low pressure in a La Nina season. It's a little unusual because typically the subtropical jet stream, which we could see very nicely here, is a lot weaker usually. Okay, so this is a little bit more amped, which again catches my eye as more wild cards here. Our polar jet stream is clearly much stronger. It has short wave after short wave after short wave after short wave marching its way across, and pretty vigorous ones too for this time of year. Typically you don't see them really wound up like this. So there's a lot of activity going on here, and you can see that our next system setting up just in time for Friday, marching its way through. The model guidance here, and I'll walk you through this. First of all, notice our 500 millibar pattern here. Now remember what I've been talking about with the trough around Alaska? Take a look at that. Look at that continuous theme on all the model guidance. We do the GFS with also spin about tropical systems. You see European ensemble guidance. So what does this tell us? Well, it tells us that we're in an environment where we can support troughs building into the eastern United States. And so, combine that with our new model guidance here. I'm going to provide a little bit of good news for you guys looking out for fall. For Friday afternoon, we have some PVA here. It's not very strong, but enough to produce some scattered showers and thunderstorms. But notice our polar air mass. It's a little bit stronger. Now for the weekend, the trough kind of minors out. So what you end up with is this stationary front hanging around and some pesky showers. Not a washout, but just a real pain in the neck in terms of trying to get some clear skies. But overall, I mean, we need the rain, so I don't think too many people are going to worry about a pesky shower. But notice, we're not seeing any surge of heat. Want to really get happy? Well, take a look at this towards the end here. As we end August and move towards the Labor Day weekend, we start to establish a rather deep trough building down into the eastern United States. And if we see this trough axis take this type of orientation, you're on the backside of this trough, which means you're in the convergence and confluence zone. That means high pressure. And oh, by the way, high pressure with a very cool polar air mass. We could be talking about, in theory, for the first couple of days of September, our temperatures, high temperatures in the 70s, low temperatures in the 50s. Yeah. Now, I think this might be a little bit overdone, tad, but I like the overall theme because it matches what's going on in the Pacific and it matches with what's going on with the tropical forcing. It makes a lot of sense. I think that this probably is a little bit overdone, but certainly it looks like the Labor Day weekend looks like it's going to be dry and beautiful out. So if you have plans for that weekend, preliminary right now is get ready to enjoy a wonderful weekend and enjoy some outdoor activities. So that's where I'm at right now with all the observations. A lot of things catching my eye. I'm really, really interested in the evolution of the stratosphere with all this water vapor and the highest levels of the stratosphere combined with an active sun and how that impacts the stratosphere and the ozone development and how all these factors interact that we've never observed before. We've always had theories, but we never seen and observed. So, ladies and gentlemen, we are literally going to be able to test out our theories, our model guidance, everything we base on stratospheric analysis and theory this winter live. So expect a lot of error because it's going to get crazy, but it's going to be a heck of a challenge. So now that I've gone through that, I'm going to first drop into our live chat here and the premium live chat. The air horn went off again. I have to figure out what's causing that.
Yeah.
I don't know what.
Right in my ear every time.
Sorry. I apologize. I don't know what. I'm gonna have to go through the data and see what's causing that. I don't know. I think the system's just excited that I'm doing live chat. I have no clue, but I do apologize. Cars before I would trust Joey Izzo talking about cars before I trust it.
It's a default thing it does whenever live.
Yeah, I gotta fix that. Yeah, the 18Z GFS, it's the fool's gold of model data. The 18Z GFS, I don't bother looking at 18Z model guidance, even with winter storms. Only time I use 18Z model guidance is if I'm looking at the HRR. I don't even look at the NAM for that. I just don't trust it. I've been burnt by it too much. How many times in the winter have we seen the 18Z model guidance come out and put out like 30 inches of snow down the I-95 corridor and everyone get excited and everyone, you better change your winter forecast because the 18Z NAM and the 18Z GFS put out an obscene amount of snow. And then the 0Z comes out and everyone's on suicide watch because it dropped down to something more reasonable, like 8 inches of snow, you know? So I don't trust the guidance at all. So, you know, that's just my opinion. Let's see here. Did the rain earlier this week help moisten the boundary layer so that storms won't die out so readily as they move towards the New York City metro? That's a great question. The answer is no. The reason why is because the rain, this was not a steady, moderate rainfall that reduces the that increases the moisture content in the boundary layer and the soil layer. We had a very heavy rainfall in some locations, 2-3 inches of rain. And the problem with that is that it just washes right off and heads right into the drain. What you need is a several days of a light to moderate, dare I say even just light rain and drizzle, just to start to get that water into the soil and moisten it up. So that way when you do get a heavy rainfall event, it takes most of that into the soil and absorbs it, which then starts to eliminate your drought and allows your plants to grow and all that stuff. All this heavy rain did was increase our precipitation anomalies, improve that, but it didn't actually get into the soil because it just washed right off. What we need is a steady light to moderate rain, which is why I'm very concerned about tropical rainfall coming in. What you need is a steady state. You don't want that heavy burst. So I don't think it really did. It doesn't hurt, but I don't think it reduced the problem. For proof that the science is never settled, note how the Webb telescope pictures of faraway galaxies are raising serious questions as the viability of the Big Bang Theory. Science, I never like to use the word settled science. The only thing that I could settle in science is that if you drop an apple on someone's head, it's going to hurt. I think that's pretty settled, right? Gravity is a thing, But when it comes to atmospheric science, I never like using the term settled because there's so much we don't know. The problem, the people who use the word settled science are politicians and policymakers, because politicians and policymakers need a known quantity. Okay, scientists are very comfortable with saying I don't know. We're very comfortable with doing that. That's the whole basis of why we got into science. Whether you're talking to a doctor or a chemist or a meteorologist, we all start off at the basis of saying, I don't know and I want to find out. And we embrace it. We love it. We love the challenge. Policymaker and a politician hate that word because they have to act like as if they have all the answers. And so, thus, settled science. Science is never settled, nor should it ever be. Question everything. But at the same time, don't buy into conspiracy theories or any kind of crazy nonsense. When someone brings a theory to you, ask them to show you the data. Most scientists will do so without any hesitation. In fact, they're excited to do so. But also make sure that you can verify that data, which is why I prefer using peer-reviewed science and peer-reviewed journals. That doesn't mean I don't ask questions and sometimes wonder, I wonder if they got this right or that right. But in terms of the data, usually there's a good establishment of data control, which you don't tend to see in a lot of social media, science-y type publications. If you see anything where I have this spreadsheet and it doesn't provide you where you got the spreadsheet, where you got the data, how to reproduce the data, stuff like that. Those are all very important things. This is stuff that you learn in high school science class. Okay, so it's kind of a refresher from senior year science, right? Or even freshman college level science. The first thing you have to do when you're looking at a scientific data or scientific paper is the ability to take the raw data and reproduce it yourself. If you can't do that or you don't give that to the professor to reproduce it himself, you fail. Why? Because then you missed a key portion of the scientific method. Okay? So just remember that. I just want to put that in the back. Just remember that. Looking at Earth News School, 250 millibar polar jet has really strengthened, but there is one very long streak that is pretty much straight across part of Asia. Yep, that's pretty much normal for this time of year. If that persists, sets up over the Pacific into the West Coast, there's going to be a lot of disappointed winter weather lovers. Yes, but remember, we're still in summer. We're in completely different wavelengths, and also there's a lot of different factors that get involved with the jet stream that are not in place right now. So I never extrapolate what's going on now to what's going on in the winter in terms of direct extrapolations. So I'll just leave it at that. Southern Hemisphere has the roaring 50s and shrieking 60s, which are basically high latitude stretches of ocean with fierce winds. Exactly. Do you see any scenario where the tropospheric jet could be decoupled from the stratospheric vortex for any significant length of time? And if so, what would be the factors that would bring that about? There would have to be some sort of serious decoupling with the QBO, which is your 30 to 50 millibar winds, combined with very strong mountain torque, which is like a very, very strong negative AM atmospheric angular momentum factor over Asia to start to set that in motion. It's very difficult to pull off. It creates complete and total chaos, so it might fit my chaos theory idea for the winter. But it's not something I would ever forecast or be confident in. It would be something where I'd have to actually see it actually happen. And then once we see that influence the steady state environment, then we could take that and extrapolate that forward. Model guidance would be completely worthless 5 days out, or maybe even 3 days out. And you'd have a lot of uncertainty and a lot of surprise events. You could end up with a lot of storms getting kicked out to the east, out and missing us, or you could get perpetual winter storm after winter storm on the East Coast. Don't know. Everything's open then, because you're decoupling everything. Rob Allen asks, so this question is going to make you mad at me. Okay. But based on everything you are seeing right now, what seems to be more likely? A hurricane coming up the coast impacting us, or a major blizzard impacting us this winter? I could see both happening. Let's see, there's a wide variety of possibilities. You could have a major hurricane impact the East Coast, but it's only one. The rest of the season's quiet. With changing dynamics in the atmosphere, you can get a blizzard or 4. It's all up in the air. I wouldn't say one's greater than the other. I think it's harder to pull off a hurricane than a winter storm, though. Any tropical activity in the Western Pacific, is it still quiet? If so, how? So really long stretch of no activity. No, there's actually some activity out there. Let me see here. I'll go back to current storms. Here we go. Tropical tidbits is really great. We have one that's passing to the east of Japan. It became a strong hurricane, I think a Cat 2, but that's heading up towards the Aleutians. It's going to enhance our trough, which is going to enhance our trough around the Aleutians, which will enhance our trough over the eastern United States, which teleconnects very nicely to the cool weather pattern that we have showing up in the guidance. That's pretty much it right now. We had another one that was tracking towards China, but that pretty much fell apart and decoupled. Is the MJO picking up at all, or still basically neutral? Pretty much neutral. La Nina is dominant. Is there any connection between a stronger than usual subtropical jet stream and the volcanic eruption, all this stuff it put in the upper atmosphere? I haven't seen any concrete connection. I would say, based on what I'm seeing right now, that we have yet to see the impacts in the northern hemisphere. We're starting to get that evolution take place now in the highest portions of the atmosphere. Okay, the subtropical jet stream's down here, way down here, and the influences in the stratosphere are way up there. Okay, so I can't really make that connection. I don't have the data to make that connection. I think that it would be irresponsible for me to make that type of declaration without any real significant data to support that theory. I think because of what's happening with the above normal cold heights in the mid latitudes, that we could be seeing an enhancement in that respect. But I'm not sure whether that is a climate change factor or a volcanic factor. I can't really separate the two just yet. If we get that for early September, that would be awesome. Well, perhaps. Let's see. Let's check out YouTube and see what questions we got there. Good evening, Judy. Good evening, Mark. Let's see here. How long does it remain quiet for the hurricane season? Well, action's about to pick up, which is typical for this time of year. When do you expect the dust to break up in Africa? It's actually starting to break up now. Two good questions already, right off the bat. So that's good to see. We have a pretty nice community here, 28 people, not bad. Pretty busy for this time of year in the summer. So great questions as always. And already at 8:35, not bad. Taking a look at our observations, notice the influence here of our dry air coming in. Look at the dew points in the mid-50s. You can clearly see we have a nice little trough here. That southerly wind really does its job coming right off the Atlantic with dew points in the upper 60s to lower 70s on the ocean and Monmouth County coastline and along Long Island. But look at those 50s. Man, if we get that really locked in tonight, get enough clear skies and light winds, those low temperatures are going to plummet. And we're going to have a nice little thermal gradient setting up on the Jersey Shore and interior central New Jersey. So we'll see how that works out. How do you feel about the sweep? Okay, I might as well answer this. Baseball question. I would say that the Mets swept the Yankees at their home. Yankees swept the Mets at their home. I think the Mets were at the end of a very long and hard road trip. Would I have liked to? I thought maybe they'd get a split, but they just didn't get the big hit. It happens. It's not the end of the world. So just go with that. You're not going to win every game. That's why they play 162. I would say this. I wish, I saw the new schedule come out for this year. I wish Major League Baseball would put the Met-Yankee series during the weekend rather than during the middle of the week. Look, a lot of people like to go to that. A lot of parents like to take their kids to that. You can't do that at 8 o'clock at night on even during the week because you got to go to work and all this other stuff. Put it on the weekend. What are they doing? It's just silly. But why am I not surprised with our manager? But so I would say that for the year, season series split. The important thing is the playoffs. That's going to be very interesting. And I think in the long run, I think the Mets will be just fine. Do I have a favorite football team? I do. It is the Kansas City Chiefs. And I've been a Chiefs fan since I've been 8 years old. Since I was 8 years old. Some say I'm still 8 years old. Who knows, you know. Let's see here. The thing most notable to me about the Sahara Desert dust is that even the areas with a lot of dust now have breaks between them and minimal dust. I agree, which is why I think that we're going to see this come to an end and our Atlantic season really start to ramp up in a big way. There is a lot of energy out there in terms of warm Atlantic waters. So don't be surprised if we go from nothing to like 5 named storms at one time, which is going to be just glorious for me to deal with. But don't be surprised if you see that and us catching up real fast. So definitely keep an eye on that. I agree, Card. I think both teams, when healthy, are going to be really good. And yeah, Len Dawson did pass away. Honestly, everyone thought because he's been out of the public eye, that he already had passed away. Because sometimes that happens. Like you don't realize, like you don't hear from somebody for a long time, like a sports figure, and you think that they're already passed away because they do tributes and stuff. But then everyone found out that he just passed away, and everyone's kind of surprised. So it's funny how that stuff kind of works. Let's see here. Some really great questions, guys. Absolutely outstanding questions. Now, let me just go back here to the volcanic data. I want to make sure the person, if you want to follow on Twitter, check out Louis Melian. for more data on the volcano. He's actually studying it via NASA's Jet Propulsion Laboratory. So he has a lot of great information. I got the latest news story from climate.nasa.gov. So it's very interesting if you read this article exactly what is happening and why it's so important. And the reason why I'm just kind of interested in what's happening here is that typically you do not see this signal where you see very cold stratospheric conditions in the mid-levels, and then at the same time in the high latitudes the exact opposite. It's very rare. Even in the southern hemisphere you typically don't see that. So it kind of like it's basically like everything's flipped on its head and you don't know what to make of it. And so this is the result of it. This is at 850 millibar temperatures and anomalies. And you can see the area where the mid-levels, okay, this is towards the equator. And here's your mid-levels. And look, this is like in correspondence, if you flip this, this would be kind of like the mid-Atlantic area in New England. So you can see waves of very cold and very warm conditions, very volatile winter down there in South America with a lot of waves of cold and let's see here. Let's see if we can get South Africa. Actually, you know what? I want to do Australia. So again, one of the dynamics here is that you have a lot of open water here. So that's always a factor. But look at this winter. Again, kind of flip it where your North Pole, everything's coming down. In this case, everything's flipped. But what I'm taking from this is that in their season, they're getting a lot of swings back and forth. It goes from very cold to very warm to very cold. The last time I saw winter like that, you ended up with a lot of dynamic blizzards followed by heavy rainfall events, a lot of flooding, and a lot of damage. So that's very, very interesting. That leads to a lot of complication here. Take a look at the 500 millibar heights. Let's see. Let's do height anomalies for this. And we don't normally look at the southern hemisphere, but this is a good way to kind of study to see, okay, the environments in place in the southern hemisphere, how is the 500 millibar pattern and the 850 millibar pattern reacting as a result? And we're seeing in this environment, look at the enhancement of these ridges. Look at that. And then look what's happening in the higher latitudes. Okay? So your higher latitudes are starting to set up these little blocks. And those blocks, under those blocks, you're getting these below normal heights over Australia and these very cold temperatures. So you can end up with like a storm here and a storm here and just a lot of volatility. So what we could take from the environment in the southern hemisphere, and again, taking the fact that you have more land mass in the northern hemisphere, a lot more volatility involved in that, a lot more torque. Even in an environment where there's less torque and less chaos involved with that, and less potential for high latitude blocking to lock in because of that, you still have a very chaotic environment, a very volatile environment. And it's something that, again, it's just going to be a real challenge to forecast for. Does anyone have any questions about the upcoming weekend or, of course, Labor Day weekend? I know that most likely people have questions about that. This is a good question from Judy. Can you use Australia and South America a gauge example for a winter to come this year? I normally do not, because of the fact that of the different dynamics involved in terms of how the polar vortex evolves. For example, in the southern hemisphere, the polar vortex develops over a continent, so it's far more stable. Whereas in the northern hemisphere, it develops over the water, and you have sea ice factors and a lot of thermal gradient factors involved, so it can become a lot more unstable. You have a lot more torque and friction factors to consider at the mid latitudes because of Asia, Europe, and North America, where you have more open oceans in the southern hemisphere. And typically, the atmosphere as a whole, what happens in the southern hemisphere doesn't always matter in terms of the northern hemisphere. This case is different and unique because we're dealing with a volcano and we're trying to understand in a scenario where we've never seen it before, in terms of the moisture, the water vapor being thrown up into the stratosphere, how does that impact what we normally would expect, in this case in the southern hemisphere? And by looking at that, we're trying to extrapolate, okay, so what would that mean for the northern hemisphere based on all the other factors that we know? So we're taking a unknown and we're taking our known unknowns and we're trying to extrapolate and figure out how do these factors all interact. Normally, I wouldn't give a flying patoot what is going on in the southern hemisphere in terms of the winter for the northern hemisphere. But this is a very special case. And typically when you're dealing with volcanoes and influences of this type, especially when you're dealing with water vapors, see what's different about this volcano is that this one threw up a ton of water vapor, not just particulates like soot and sulfur. Water vapor leads to cooling in the stratosphere and warming in the troposphere. But again, normally you would expect that to be more of an influence in the higher latitudes. But based on what we're seeing in the southern latitudes, in the southern hemisphere, it's happening in the mid latitudes, which I was not expecting. So it's kind of flipped. So it has my attention because I'm like, all right, there's one theory out the window, and we're just starting. So how do we deal with that? Okay, so how do we work with those theories and work with what's actually evolving here? So I'm just being upfront. There's a ton of unknowns we don't know. Any changes to your ideas as to storm potential with Friday's cold front? I like the idea of scattered showers and thunderstorms because, let me go back here. Here we are. The setup here, I don't really like the setup here in terms of any severe weather right now. I can't rule on isolated severe thunderstorm, but I don't see this as a major severe weather outbreak. Let me pull up the winds here. Let's see if I can find that. I think this is it. Okay, 1 second. So, in terms for Friday afternoon, your jet streak dynamics already, go to 54 hours out. Your jet streak dynamics and divergence and diffluence is focused over towards Maine. So there's that aspect out. The other jet streak is focused out over the Atlantic. So there goes that. So you're not really dealing with strong upper level winds. You're not really dealing with any type of strong vertical wind shear. And also the orientation of the cold front, which is like this, and the upper level winds are nearly parallel, which means we're seeing a stalling cold front with a lot of loss of momentum. We're seeing that at 700 millibars and at 850 millibars. Notice your low level jet, which is kind of what you would look for in terms of severe weather, is all focused towards New England. So maybe you could see a severe thunderstorm spark around Connecticut, but I think most of that's going to be focused towards Massachusetts. Even in that environment, all the winds are kind of aligned from the surface all the way up to 500 millibars. And you're not really seeing much of a support for any type of speed shear. You're talking about maybe at most 30 knots, which isn't all that impressive, to be honest with you. So I like the idea of scattered showers and thunderstorms, but I really don't see any type of dynamic that would say, hey, look, this is going to be a real significant severe event. And even the vertical wind shear is well, negligible, really. I mean, that's pretty weak when you're talking about around 20 to 30 knots around the region. So what you'd want is to see this signal. If you really want severe weather, you want this signal here to be focused over the mid-Atlantic, and you don't really have that. So I like the idea of scattered showers and thunderstorms, but we'll see how that all plays out for Friday. I don't see this weekend at all being a washout in any way, shape, or form. In fact, I think most of the weekend will basically be a mix of sun and clouds, and then you get a passing shower from time to time. So overall, not too bad at all. All right, I'm going to take some final questions, and then we will call it a night. And then I'm going to hang out, watch some CSI. So let's see here. The older stuff. I like watching the older shows. You know, fun, nostalgia. What can I say? And you're welcome, Judy. Absolutely. Also add in that this volcano threw water vapor all the way up into the mesosphere, well above the stratosphere. Yet another factor. Yeah, I mean, it almost would be easier if it didn't throw up the water vapor and just threw up the soot. You know, a lot of rocks and whatnot. Then you could say, okay, this is going to block out the sun, cool the atmosphere, probably cool us down a degree Celsius for a year or so. So it'd be easier to forecast for. This is a real challenge. It's going to be interesting. What I want to see is that you have this water vapor all the way up into the mesosphere, and then you have an active sun, you get a CME like hit the Earth. And how that interacts with the water vapor, how does it split? Does it cause a split where you get a lot of O2, a lot of oxygen, and then a rephasing of a burst of ozone? I don't know. Wow, I mean that's just really difficult to forecast. And or with the interaction of the sun with an active event, does it enhance the water vapor, and does it lead to a development of upper level cloud cover, which would reduce the albedo and knock down the influence of the solar influence during the winter? Don't know. I guess we'll find out together, right? I mean, that's going to be a real challenge. What do you think of Judge hitting a home run off Max? Well, after striking out 5 times, it's about time, I guess. You know, he isn't going to get struck out forever. He's too good of a hitter. I would say that, look, you know, the Yankees are a good team. I don't understand Yankee fans, to be honest with you. You guys are like 35 games over 500, and you're freaking out because you didn't get another All-Star at the All-Star break. I don't get the trading of Montgomery. That was weird, but your team is fine, okay? Try being a Pirates fan, okay? Those guys have issues. The Yankees are going to be just fine. Will they win the World Series? No, because the Mets are. But still, they are a great team. Enjoy the season, man. That's all I could say. You know, when it comes to the Mets, I don't have any problem with the Yankees being successful. I got a problem with certain Yankee fans saying 27 World Series like as if they were on the teams for this since 1910. Like, give me a break, okay? Let's see here. All right, I think that is it. Oh, hold it. I don't get the trade for Montgomery either. The big problem for Yankees is the entire back end of the bullpen is out for the year. Yeah, but they're winning. We'll see what happens. Look, you know, the one thing I love about baseball, and the reason why I love watching baseball, is that you have all these experts, and they have like all, you know, the statistics, and this person's going to do that, and all sort of stuff. The fact of the matter is that every game, every night, you can get someone coming up from Double-A that just surprises the heck out of you, shuts down the other team, and has an amazing run. And all these so-called experts didn't predict it. DeGrom, one of the best pitchers that we've seen in a decade, he was projected to be a bullpen guy, and the so-called experts thought at most he might be a fifth starter. You see? Experts don't know much. That's why you just have to enjoy the game. That's why I love the game. Because baseball is a perfect example of chaos theory. So I think with that, I think we're going to close it in for the night. Thank you again for dropping in. Outstanding questions once again. Of course, I'm not surprised because you guys do an outstanding job. I hope you have a wonderful weekend. And as always, stay safe out there.